The questions about angles really tend to trip students up. And the reason is when we draw these molecules on paper, we're drawing them two-dimensionally. We're drawing them flat when they're really not necessarily flat. So what you need to do is count the electron domains around the atom that they're talking about. Remember that if you have two electron domains, your structure is going to be a linear molecule with 180 degrees as your bond angle. If you have three electron domains, that is going to be a trigonal planar electron domain geometry, and the angles are going to be about 120 degrees. With four, the most common type, four electron domains, that's a chicken foot or a tetrahedral structure, and all the bond angles are going to be 109.5. Five electron domains, trigonal planar structures, which have two electron domain angles. You're going to have a 90-degree angle up to the ring around the middle, and then the ring around the middle is going to have a bond angle of 120 degrees. And then the fourth type, if you have six electron domains or an octahedral electron domain geometry, all of those angles are 90 degrees. Let's go ahead and take a look at some examples. So in this particular picture, I am looking at the bond angle around that oxygen. Oxygen's in the middle of the angle they're trying to distinguish. If I look at the electron domains that touch oxygen, there is one domain, a lone pair isodomain, that's two domains, three domains, four domains touching the oxygen. Since there are four domains touching oxygen, that's a tetrahedral structure, and that gives me a bond angle of 109.5. Even though it looks like 180, it's not 180. Four domains, 109.5. Let's try another one. This particular angle, angle 2, wants to know what is the angle around what looks like to be the chlorine atom. So check out your domains that are touching chlorine. Chlorine has one domain around it, two domains around it, three domains around it, and four domains around it. Four domains. Four domains is a tetrahedral geometry, so the angle for tetrahedral geometries 109.5. Let's go ahead and take a look at the next one. Carbon. Carbon here has the angle 3 is around carbon, and if we look at how many domains are touching carbon, one domain, one domain, one domain, and one domain. Four domains are touching the carbon. Four domains, tetrahedral geometry, and that angle 109.5. Let's look at your oxygen. Angle number 4 is around the oxygen. Oxygen has four different domains touching it. It has a domain to the carbon, a lone pair, another lone pair, and another bond. Four domains, 109.5, a tetrahedral structure. Let's look at angle number 5. Angle number 5 right here is around your center carbon atom. Now that center carbon has one domain touching it and a triple bond which serves as one domain. Two domains trying to get as far away from each other as possible is linear, so this one is 180 degrees apart. Angle number 6. Angle number 6 is around this central carbon. That central carbon has three domains touching it. A domain here that's a single bond, a domain here that's a double bond to oxygen, and a third domain going off to the next oxygen. Three domains is a trigonal planar geometry. Trigonal planar geometries have angles of 120 degrees. And then for angle number 7. Angle number 7 is around our oxygen atom right here. If we look at all the domains touching our oxygen, we have a single bond to carbon, we have a lone pair on top, a lone pair on bottom, and another single bond to carbon. So we have 2 lone pairs, 2 bonds, that's 4 domains, and 4 domains again, 109.5 degrees. And finally, our last example, angle 8. So angle 8 is around this carbon atom. Carbon has 4 domains touching it. A domain up to hydrogen, a domain to oxygen, a domain to hydrogen, and a 4th domain to the hydrogen. 4 domains is a tetrahedral geometry, and that, again, 109.5. I hope that helps. Take care.